4.7 goes over piecewise functions. Piecewise functions are literally part of functions that are all put together on one coordinate plane. So we're going to be looking at these functions, and then we're going to be seeing multiple functions on the same graph that are just parts of these functions, not the entire thing. Normally where one drops off, the other one picks up at. So like if you see this coordinate plane here, you have one line that x minus 2, that f of x is equal to x minus 2, where x is less than or equal to 0. That line only goes from negative infinity up to x with your x values, or up to 0 with your x values. From there, that line stops, and a new one picks up at the same x value and continues on, which you have that f of x is equal to 2x plus 1, where x is greater than 0. So with these, a lot of them that we're going to be doing is just evaluating the function. If we look at example 1, we're given the function f of x is equal to 2x plus 1 if x is greater than 0, and x minus 2 if x is less than or equal to 0. We're evaluating this function for x is equal to 0, x is equal to 4, and x is equal to negative 3. The first thing that you want to do is test your inequalities with this given x value. The first one we have is 0. So if you plugged it into the x is greater than 0, is 0 greater than 0? No. Plug it into the other inequality. Is 0 less than or equal to 0? Yes. So since that 0 is less than or equal to 0, we use the x minus 2. So we're going to do f of 0 is equal to x minus 2. So we're going to plug that 0 in for x, and we're just going to get f of 0 is equal to 0 minus 2, which is f of 0 is equal to negative 2. For that x is equal to 4, plug this in. We have 4 is greater than 0. Is that a true statement? Yes. So use the 2x plus 1. So we're going to have f of 4 is equal to 2x plus 1. We're going to plug that 4 in for x. Get 2 times 4 plus 1. The 2 times 4 is 8. So f of 4 is equal to 8 plus 1. 8 plus 1 is 9. So f of 4 is equal to 9. When x is equal to negative 3, if we plug this in, we would have negative 3 is greater than 0. That's a false statement, so we won't use that one. However, the negative 3 is less than or equal to 0. That gives us a true statement, so we'll use the x minus 2. So f of negative 3 is equal to x minus 2. We plug that negative 3 in for x. So f of negative 3 is equal to negative 3 plus 2. Negative 3 plus 2 is negative 1. So f of negative 3 is equal to negative 1. Sorry, so this should be a negative 2, not a plus 2. Oh, minus 2, I'm sorry. So minus 3 minus 2. So then this should be f of negative 3 is equal to negative 5. So what all of these mean is that when f of 0 is equal to negative 2, it just means that the ordered pair 0, 2 is part of a line that's drawn on that coordinate plane. Same thing with that f of 4 is equal to 9. The ordered pair 4, 9 is part of one of those lines that's drawn on the coordinate plane. And then for f of negative 3 is equal to negative 5, the ordered pair negative 3, negative 5 is an ordered pair that is on one of those lines on the coordinate plane. For example, B, we have f of x is equal to 3 if x is less than negative 2, x plus 2 if negative 2 is less than or equal to x, which is less than or equal to 5, and 4x if x is greater than 5. So we first have f of negative 1. We're going to plug this in, see which inequality this works in. So we ask ourselves, is negative 1 less than negative 2? No. Check the next one. Is -2 less than or equal to -1? Yes. Is -1 also less than or equal to 5? Yes. So we use the x plus 2. So f of -1 is equal to x plus 2. We plug the value in for -1 for x. So f of -1 is equal to -1 plus 2. And then we simplify. F of -1 is equal to 1. For f of -2, again, we plug these in, this -2 in for each of these inequalities to see which one works. So we ask ourselves, is -2 less than -2? No. Is -2 less than or equal to -2? Yes. Is it also less than or equal to 5? Yes. So because this one works, we're going to use the x plus 2 again. So we're going to have f of -2 is equal to x plus 2. We plug in that -2, so f of -2 is equal to -2 plus 2. -2 plus 2 is 0, so f of -2 is equal to 0. For f of 0, we're going to plug 0 in for these inequalities. We ask ourselves, is 0 less than -2? No. Is -2 less than or equal to 0? Yes. Is it also less than or equal to 5? Yes. So we are going to use the x plus 2 again. So f of 0 is equal to x plus 2. We plug in that 0. We get f of 0 is equal to 0 plus 2. So f of 0 is 2. Our next one, we have f of 3. So we're going to do 3 is less than -2. That's not true. Is -2 less than or equal to 3? Yes. Is it also less than or equal to 5? Yes. So again, we're going to use that x plus 2. So f of 3 is equal to x plus 2. Plug in the 3. F of 3 is equal to 3 plus 2. So f of 3 is equal to 5. For f of 5, do the 5 is less than -2. That doesn't work. Then we would have -2 is less than or equal to 5, which is less than or equal to 5. That does work. So once again, we'll use the x plus 2. So f of 5 is equal to 5 plus 2. 5 plus 2 is 7. So f of 5 is equal to 7. For the f of 10, we can try 10 is less than -2. That's a false statement. The -2 is less than or equal to 10, which is less than or equal to 5, is also a false statement. However, 10 is greater than 5, so we'll use the 4x. So f of 10 is equal to 4x. Plug the 10 in for x. F of 10 is equal to 4 times 10. 4 times 10 is 40, so f of 10 is equal to 40. So with that, we're going to be graphing these next. So like I was just saying, some of these are going to have open circles, some of them are going to have closed circles. You'll see here that where that x is less than 0, this is going to be an open circle. For that x is greater than or equal to, because it's equal to, it'll be a closed circle. So when you look at this, there's a couple ways of doing this. First way, you can do a function table. So you can get your values of x, plug them in, and get your y values to give you your ordered pairs. Or you can just graph the functions and erase whatever it is you don't need for those x values that are not being covered. The first way that we're going to do this is using a function table. So I look at this. I have x is less than 0, so I'm going to go all the way up to 0, including 0, even though that is just less than it, because I'm going to have a point on that 0 something that has an open circle on it. Okay, so I want numbers less than 0. I'm going to pick 3 different numbers less than 0, including that 0. So my x values are going to be -3, -2, -1, and 0. For these, I just have that -x minus 4. If I plug these values in, I'm going to have a negative times -3 minus 4, a negative times -2 minus 4, a negative times -1 minus 4, and a negative times 0 minus 4. Two negatives next to each other turn into positives. So 3 minus 4 is -1, 2 minus 4 is -2, 1 minus 4 is -3, and 0 minus 4 is -4. I'm going to have an open circle on this 0, -4. So on my coordinate plane, I'm going to plot these points, -3, -1. Go to the left 3, down 1. Then I have -2, -2. -1, -3. And 0, -4. So I'm going to have an open circle on that 0, -4. So you'll see that this line is going to continue to go to the left all the way through that coordinate plane. Now that's only part of this piecewise function. The second part is going to come for that x is greater than or equal to 0. So I'm going to have x values that are greater than or equal to 0. So I'm going to start at 0 and go up. So 1, 2, 3. I just have my x. So I'm going to have 0, 1, 2, and 3. So these are these ordered pairs of 0, 0, 1, 1, 2, 2, and 3, 3. So I'm going to have a closed circle on this 0, 0. Because I have x is greater than or equal to. So I'm going to have a closed circle there at 0, 0. And then I'm going to go 1, 1, 2, 2, 3, 3. And then I'm going to continue to go throughout my entire coordinate plane all the way to infinity. So again, I have one line that stops at a specific x value that has an open circle, and then another picks up at the same x value with a closed circle to actually include that number for an x value, and then that will go to positive infinity. For example, B, we have y is equal to x plus 1 if x is less than or equal to 0, and negative x if x is greater than 0. So another way of doing this, which is not something that I care to do, but I'm going to show it to you either way, is to graph each of these functions separately and then look at my x values that are being covered and erase whatever I don't need. So if I graph at x plus 1, I have a y-intercept of 1 and a slope of 1. So my line's going to go through my y-axis at 1, and then it continues to go in each direction using that slope of 1. So I'm going to look at my x values. I have a closed circle at 0. So at 0, where my x value is 0, I'm going to have a closed circle there, and then I'm going to erase anything that's less than that, or sorry, that's greater than that, because x is less than or equal to 0. So I'm going to erase everything that's greater than that. So anything to the right of it, I'm going to erase. Then I have x is greater than 0 for negative x. So that gives me a y-intercept of 0. And then my slope is negative 1. So I'm going to go down 1 to the right 1. So my line is going to look like this. I could go the opposite direction as well, and it would look like this. However, I look at my inequality. I have an open circle, since it's not also equal to, and I want any x value that's greater than 0. So anything to the left, I'm going to get rid of. And I'm going to put an open circle on 0. So I'm just going to erase just a little bit of that and put an open circle there. So again, this is another way of doing it without doing that function table. I don't care for doing it this way because it's not as precise, but I do like doing it with the function table so that way I can actually see those x values that are being covered. For example C, we have y is equal to x minus 2 if x is less than 0, and 4x if x is greater than or equal to 0. So when I draw my function table with this, I'm going to have two different functions within the same. The first one I'm starting with is that x minus 2 if x is less than 0. So I'm going to choose negative 3, negative 2, negative 1, and 0. I also have 4x if x is greater than or equal to 0. So I'm going to still have that 0, then anything greater than. So with my x minus 2, I'm going to use the negative 3. I have negative 3 minus 2, the negative 2 to give me negative 2 minus 2, negative 1 for negative 1 minus 2, and 0 for 0 minus 2. For the 4x, I'm going to have 4 times 0, 4 times 1, 4 times 2, and 4 times 3. Going back up top, the negative 3 minus 2 is negative 5, negative 2 minus 2 is negative 4, negative 1 minus 2 is negative 3, 0 minus 2 is negative 2. For the 4 times 0, it gives me 0, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So I'm going to have that 0, negative 2 with an open circle since my sign does not equal to, and then that 0, 0 is going to be a closed circle since it's also equal to. So all I have to do now is graph these ordered pairs on the number line and draw a line through them. So for my first function, I'm going to graph this line in red for my first function. I have the negative 3, negative 5. Then I have negative 2, negative 4, negative 1, negative 3, and 0, negative 2 with an open circle. So this one, you see my slope is that 1, so just continue to go to the left. I draw my line through these points, and I'm done with that function. I'm going to start with my next. My first ordered pair is at 0, 0. So I'm going to have a closed circle on that 0, 0. Then I have 1, 4, 2, 8, 3, 12. So I'm going to draw my line through these points now. And then I check my lines. Do I have one line that stops at a specific point and another line that picks up right at that same x value? One of these lines has to have a closed circle. One of them has a positive circle. That is true for both, so we're good. The last part of your lesson is writing piecewise functions for the graph that's given. So with these piecewise functions, they're good because they go through your y-axis. So it gives you that y value that you're starting off with. Then you can also use 2 points on the same line that'll give you your slope, and you can just write your linear equations or linear functions in slope-intercept form. So if we look at example A, this line that I'm going to look at is this one here. Look at where it crosses your y-axis. You're at -3. So your b value for this line is -3. Your slope, you're going from this point to this point, so you're going up 1 to the right 1, is just 1. So this is the line y is equal to 1x minus 3. Now look at the x values that are being covered by this line. The x values that are being covered from this line are anything from 0 to -infinity. So you want the x values to be less than 0. Does the circle that's on that 0, 3, this is a positive 3, not a -3, I'm sorry. Is that circle that's on that 3 open or closed? It's open, so we don't have a line underneath that x is less than 0. So when you go to write this part of your piecewise function, you're just going to include the x plus 3 if, what was your inequality? X is less than 0. For your other line, you're starting that at 1 on your y-axis, so b is equal to a positive 1. Now look at your slope. You're going from this point here on your y-axis up to the point 1, 1. So you're going up 2 to the right 1, so our slope is 2. This gives us the equation y is equal to 2x plus 1. So just include that 2x plus 1. And then look to see what your inequality is going to be. You're starting at 0 for those x values, and you're going to positive infinity. So we're going to have x is greater than 0. Do we have a closed circle or an open circle where that line picks up at? We have a closed circle, so we're going to include the line underneath it. So we're going to have the function of f of x is equal to x plus 3 if x is less than 0, and 2x plus 1 if x is greater than or equal to 0. So this b should be a -1, not a positive 1. So this should also be negative as well. So should this. For example B, we look at these two lines. The first line that we have, I look at these from left to right always. The first line that we have is this line that has a closed circle on -1. So our b value is -1. Our x values that we're going by are from -infinity up to 0, including 0. So x is going to be less than or equal to 0. And then my slope, I'm going from this point to this point, so I'm going down 1 to the right 1. So m is equal to -1. So this is going to be the line y is equal to -x minus 1 when x is less than or equal to 0. For my other line, I'm starting at that 2, so my b is 2. My x values that are being covered here are anything that's greater than that 2. So x is greater than that 2. It has an open circle on that 0, 2, which is why I'm just using greater than and not greater than or equal to. And then my slope, I'm going up 1 to the right 1, so that's just a positive 1. So this is going to give me y is equal to x plus 2, and that's when x is greater than 2. So to write this as a piecewise function, we're going to have f of x is equal to negative x minus 1 if x is less than or equal to 0, and x plus 2 if x is greater than 2. For C, we have multiple functions on this graph. There's 3 different ones. So when that happens, you're going to do all 3 separate and then bring them together. So I'm going to look at the one furthest to the left first. So what are my x values being covered from this one? It goes from -2 to infinity to negative infinity. So that's x is less than or equal to -2, since it has that closed circle there. Now this one doesn't have a y-intercept. So you can do this one of 2 ways. You can find what the y-intercept is by plugging in 0 for x, but we don't have an equation either. So you can continue that trend that's happening with the slope. Your slope is -1. You're going down 1 to the right 1. So that would be here and here for ordered pairs. So your y value would be that -2. So this would be the equation y is equal to negative x minus 2 when x is less than or equal to -2. Now I'm going to look at that middle line that you see there. It's a straight horizontal line through 2 on the y-axis. So automatically we know that this is y is equal to 2. Now what are the x values that are being covered by that line? You're going from -2 to +1. So it's going to be a -2 is less than x, which is less than 1. And both of those inequalities do not have a line on them, since the circles that are included on the front and back of this line are open. For the line on the right, I'm going to start my x values at the 1 and go to infinity. It includes the 1 since we have a closed circle on there, so x is greater than or equal to 1. Now again, I don't have a y-intercept here because that line doesn't cross the y-axis. However, I can use my slope, which I'm going from this point to this point. So I'm going up 2 to the right 1. So my slope is 2. To continue that trend and go down 2 to the left 1, to see that my y-intercept for this line would be -3. So b would equal -3 here. This would give me the linear equation of y is equal to 2x minus 3. And again, my x values that are being covered are anything including 1 up to infinity, so x is greater than or equal to 1. When I write this as the piecewise function, I'm going to name it f of x is equal to, I'm going to have 3 function rules that I'm working with. The first one is that negative x minus 2 if x is less than or equal to -2. Then I have the y is equal to 2, so it's just going to be the 2 if negative 2 is less than x, which is less than 1. Lastly, I have that 2x minus 3 if x is greater than or equal to 1. So you'll see here that at the very top, looking at my inequalities, they should include the numbers from negative infinity down to positive infinity. So what that means is that top function in my piecewise function should include my lowest x values that are being covered by that line on the coordinate plane. Then my middle one are my middle x values that are being covered by that line on the coordinate plane. And my last one will be my highest x values that line's covering for that function.